the math guys teach radians. And the reason we like radians is it makes all the formulas easier. The formula for arc length is super easy in radians. If you're using degrees, it's not. If you're in a calculus class, you want to always use radians, not degrees. Now, somebody says, but in my calculus class, sometimes we can use degrees. Yeah, sometimes. But you can always use radians. All right? Radians are what you want for all upper level math courses. You'll never know about degrees once you get past Calc 2. All right? Physics, one of the things I hate about physics is they still like to do everything in degrees, and so they have a little added part to every one of their formulas that you don't need if you just start out in radians. All right? But radians are a little bit hard to understand for students, I guess. But here we go. What a radian is, let's talk about radians. Radians is actually a length of measure. It measures length. And what a radian really does, it measures the length that you would go along the circle right here. That's what it measures. It's how far you would go. Now, I think since the radius of this circle is 1, okay, there's 0 radians. And here's the catch about radians. You don't even put a little r up there. You don't even put any notation up there. Radians fit so well into the math world that if we see an angle has 0, that means 0 radians. Same place as 0 degrees. Now, since the circle has a radius of 1, what is the circumference of the circle since it has a radius of 1? Circumference of a circle with a radius of 1 is 2 pi. I'm going to talk to y'all's geometry teacher. We need some lower grades. 2 pi. The circumference of a circle with radius of 1, circumference is equal to 2 pi r. So the circumference of the unit circle is 2 pi times 1. 2 pi. So if you started here walking, and this was in feet, this was 1 foot right here, you would walk 6.2 something feet. You would walk 2 pi feet. And pi is what? 3.14. So if you started walking around the circle, this would be a little over 3 feet here, and this would be a little over 6 feet there. Y'all do realize circumference is the distance around the circle. All right. Now, with that in mind, these are radians, and I will sometimes put a little r up there to help children, but you're not supposed to. Okay, what happens if you're walking all the way to here, you walk 2 pi. So what happens if you only walk to here? How far would you walk? 1 pi. And with that in mind, how far would you go if you only walked to right up here?
1/2.
Pi over 2 or 1/2 pi. Very good. Now, here's where it may get a little weird. 30 degrees, 30 degrees is 1/6 of the distance from here all the way to here. Because how far is it if you go all the way to here? It's 100 and what? 80. And so 30. So 30 degrees is only what? 1/6 of 180. Well, it's also 1/6 of how much? Pi. Is that all right? That's the key right there. That gives you the pi over 6. Now, if you think about 45 degrees, that would divide this thing into what? How about, the whole thing into eighths, but how about just from here to here, divided into what? Just what? Fourths. And the reason I want to go to here is because I got a whole pi. You can take 1/8 of 2 pi, it would work. So I'm just going to take 1/4 of what? Pi. Pi over 4. And these are the units. In other words, if you're doing calculus and they tell you something's 45 degrees, you don't use 45 degrees when you work the problem. You use pi over 4. They're probably going to start off with telling you pi over 4, but that's how far. So right here, you're going to work about half a foot to walk here. Because it's a 6 of 3, right? Remember, pi is what? 3.14. Now, 60 degrees is what portion of this whole thing? 1/3. 1/3, pi over 3. Now, here, 120 degrees is not 1/3, it is how many thirds? 2/3. Now someone says, Mr. Evans, am I going to just learn these and memorize it? If you have to, yes. So that's 2/3. 135 degrees. Okay, there's 1/4, 2/4. So how many fourths is this? 3/4. And then this one's a little bit of a pain because there's 1/6, 2/6, 3/6, 4/6, and then how many 6 is that? 5. If you're not sure, watch this. It's 150 degrees, right? Do 150 over 180, and that reduces to 1. That reduces to, divide 30 into there, 5, 6. And so it's 5/6 of the way, and all the way is 1 pi, so it's what? 5/6 pi.
Does that work with all of them?
What, the little trick over 180? Sure does. You can ditch it, sure does. Matter of fact, Mr. Thomas, on the back of your unit circle, you're going to write a formula. Now, today, I don't know where you're going to put it, but when you get your really good unit circle, you're going to write this formula on the back. This will go on the back of your unit circle. Radians over pi is equal to degrees over 180. The whole catch is, got it? I got a zap. Zap yourself back there. There you go. This formula converts radians to degrees, or it converts degrees to what? Radians. I'm giving you this formula because in physics and in geometry, they gave you 2 different formulas. You don't need 2 formulas. That works either way. So, since the man just mentioned that, we'll go down here and we will put in some more degrees. We already know this is 210. This one was what? 225. This one was 240. 270. So then 300, 315. And I should have made those where I had room to write my radians in there, because you always want to put the radians out beside the edge of the circle, because the radians are what you're really going to be using most of the time. And you could just use our formula over there and convert every one of these to radians if you wanted to. Or you could go, well, that's 1/6 more than pi, right? Does everybody agree that's 1/6 more? That's 7/6 pi. That's 1/4 more, so 1 plus 1/4 is what? 5/4 pi. And then 1 plus 1/3 is 4/3 pi. See if you can do the rest of them. See if you can go off. And if you need to, you use this little formula right here. You can just say, oh, it's 270 degrees. 270 over 180 equals radians over pi. Reduce that. 3 halves equal radians. Okay. Anybody got the next one? What's the next one? What's 300 degrees going to be? Oh, come on, it's Monday morning. I'm doing everything I can to pour knowledge into your brains. 300 degrees, figure it out. Well, if you want
5
to.
over 3.
How much?
Is it 5 over 3?
5 over 3, yes sir. Just leave the wheat behind. What's the next one? 315 degrees is 1 plus 3/4. 7/4. Yeah, you can just keep chatting. 7/4 pi. And this one's 11/6 pi. 11/6. And then 2 pi. Now, here's the only problem you're going to have. Negative degrees, I don't care about negative degrees really, but I care about negative radians. All right? Now, so if you go around, it's 1/6, 1/4, 1/3, 1/2, 2/3, 3/4, 5/6 pi. And then really all you got to do is start adding pi plus this one, pi plus 1/4, pi plus 1/3, pi plus 1/2, pi plus 2/3, pi plus 3/4, and pi plus 5/6. And for those of you that learned to add fractions back in the day, this isn't bad. Don't be mean to the children. All right, now, I'm going to get rid of the degrees in mine because I don't really need them. And we're going to chat about negative radians. And when you do yours, when you do your final one that you're going to need to take with you to calculus class and all that, you need the positive and negative radians, but you don't need the negative degrees really. You just need regular degrees. Okay. And to be honest, you only need negative radians back to right here. Here's where you need your negative radians. This is right here, negative 1/6 pi, or negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. And that's as far back as you've got to have your negatives. All right? Yeah, you can keep going all the way around the circle if you want to, but this is how far back you're going to use in calculus right here. All right? There's going to be some things they're going to tell you to look for the answer between negative pi over 2 and pi over 2. All right? It'll be called an arc tangent. And when you're looking for the answer of an arc tangent or arc sine, you look for your answers between negative pi over 2 and pi over 2. All right? So you don't need this back here for negatives. All right. And those are what radians are. There is the linear measurement. Radians is a linear measurement, and it's much more versatile than a degree measurement. It will measure the same things as a degree, or it will measure a straight line. Degrees will only measure an angle. So they're very limited. All right, now as far as work to do with them. Yeah, I'm going to look at the book to see what I'm about to sign. Somebody said I wasn't doing a very good job of that the other day. I was just making it up. I'm going to go right through the book and see if I can cover an example of each type. Oh, now, one thing, does everyone realize if I just told you it was 1 radian, that's 1.57. Is everybody okay that that's 1.57? So 1 radian is going to be somewhere about here, right? Matter of fact, if you think about it, that's 1 point something radians, right? 3.14 divided by 3. A whole number can be a radian, like 5 radians. Well, that's 3.14. That's 3.14 plus 1.57. So 5 radians should be somewhere over here. Is everybody okay that 6 radians is about right there? You get how pi is 3.14. So if I give you a whole number radians, that's okay? Okay? Because you're just not multiplying that whole number times pi. It's just whatever the number is. All right. It says convert the degree measure to radians. Okay. Radians to 100, radians to pi equal to degrees to 180. Now let's say I wanted you to find out what 80 degrees was in radians. Yeah, I'm going to pick one that's not on the circle here. I'm just going to pick something out. 80 degrees. Radians over pi equals 80 over 180. What I'm doing is I'm going to convert 80 degrees equals question radians. That's the first example today. How to convert degrees to radians. Which we've actually already done, right? Did we do that back here? So, radians equals, reduce that, 4/9. And then multiply by your pi. Leave the pi. Don't get a calculator out and put 3.14 in there. Leave the pi. Leave the pi. All right, now, is that cool? Pretty cool so far? All right. Now, everybody happy? Yeah, we'll do that in a second. I have 4/8 pi, no, 4/7 pi radians, and I want to figure out what that equals in degrees. Okay? All right? You got 4/7 pi radians, and I want to figure out what that's going to be in degrees. So I do 4/7 pi over pi equals degrees over 180. And notice what happens very nice for me. What are the pi's? Pi's divide out. See where the pi's divide out? And so I get 4/7 equals degrees over 180. So then I just multiply. Hey, how are you doing? Somebody was very disappointed you weren't here this morning. And folks, honestly, I wish I would have used the 7 there because that's not going to be real pretty, right? But it's going to be 4 times 180 over 7. And 4 times 180, 720 over 7.
Did you divide that by pi and cancel it out?
Yeah, the pi is divided out right here because there was a pi in this one. All right. And now you're going to lead. You're going to lead to the next question. All right, next one. On this one, I'm going to do another one of these with radians. Ma'am?
I wasn't done writing.
Oh, that's all right. It's on the film. Okay, radians. I have 1/5 radians. Notice it does not have a pi after it though, because I've already told you radians really don't have to have that pi out there, do they? Remember that? Said that, right? So when you use the formula, you're going to get 1/5 over pi equals degrees over 180. And here's the problem. That pi is going to stay in that denominator. See that pi right there? It's going to stay there. So you'll get 1/5 pi times 180 equals the degrees. And 5 goes into 180, 36 over pi equals your degrees. And why kids have a fit about this is they don't expect to see a pi in the degrees. But it is, because pi is just really what? 3.14. So that's the one that throws everybody, is when they have to convert them that way. All right? So far, so good. Does everybody understand why there's still a pi in that degree measurement? Because there wasn't a pi in the radian measurement. Divide out. Take a look at that. Make sure you feel good about it. Yes, sir.
If there's a pi in all the radians on the whole circle, then why would there be a radian that doesn't have a pi in it?
Ooh, I measured something in radians and it came out to be 3 instead of exactly pi. Or I measured something and it was small. This is actually 0.5, right? I measured something that was in here somewhere, and instead of using the pi, I just said, okay, that's 0.5 and it's half of that, so it was 0.25. All right? So instead of using the pi, I'm just converting them to decimals and rounding off to whatever I need. But you have a good point. Generally, all the ones we're going to see are going to have what? Pi. But I want you to be okay with the idea that if you just get the number 3 radians, that's going to be somewhere over here. Because that's 3.14 radians. All right? That's 3.14 radians. All right. Now, the good news is, if I ask you, what is the tangent of pi over 4? Everybody in here know that's 1? Does everybody realize that if they give you anything like this, you just look on the circle? Yeah. All of those, you just look on the circle, folks. I want to know the sign of negative 2/3 pi. Okay, well, that's negative 1/3. Right here is what? Does everybody agree that's negative 2/3 right there?
Mm-hmm.
That's negative 3/4, isn't it? You might want to go ahead and put those all the way around on your circle, since I think some of y'all are a little bit hesitant. Someone's watching this going, well, he's not even telling them how to do that. Yeah, because they ought to be able to just look at it and tell. That's a mean Evans. Whoa, and I missed one because I said that. See? Evans, you should have been nice. Negative 5/3 pi. Negative. That's negative 5/3. That's negative 7/4. And then that one right there is negative 11/6 pi. And then negative 2 pi. All right, so there gives you the negatives if you need them. And you can work them out if you want to. You can take negative 30 degrees, negative 45 degrees, and use the formula and convert them. And I should make you do that, but I didn't. So the sign of negative 2/3 pi is negative 1/2 common negative square root of 3 over 2. So does everybody know this negative square root of 3 over 2? Is that okay? So what's the whole deal with radians? It's just a different way to determine where you're at on the circle. It's just a much more useful way than degrees. Honestly, degrees, when we teach you degrees, it's because you have there's some kind of weird thing where you already understand degrees a little bit. You know about how much 30 degrees is. You know about where to put 150 degrees. Well, with radians, you're going to have to learn that same idea in your brain. Pi over 4 radians, third of pi. You know, you're going to have to learn that in your brain as to where you're pointed at on the circle. And the reason, and this is the serious reason to learn how to do radians. It makes all the formulas easier in the future. And it's the only thing that works in calculus all the time is radians. All right. I mean, if we could, when you were back first learning about triangles, we should have just started off, instead of saying 30, 60, 90, we should have said pi over 6, pi over 3, pi triangle, pi over 2 triangle. Okay? But wouldn't that have been really confusing and real pain? So no, we didn't do that. We started off with degrees. All right. Now, if you look on a section on the assignment, there's a part that says radians. There's an assignment down there, radians. And it's already got the 2 pages that you're going to work on. Just work the odds off those 2 pages. There's 3.1 from the law textbook, Margaret Law's textbook. All right? And you can look at that in just a second. Now, I'm going to get your attention for something else I want to tell you about. And here we go.